Hi everybody, my name is Julien and I'm Chief Evangelist for Hugging Face. In this presentation, I would like to introduce you to building natural language processing applications with transformers. A few years ago, deep learning exploded onto the stage, and this was caused by an alignment of planets, so to speak. So the first planet was the resurrection of neural networks. Pretty old technology, but brought back and applied to computer vision, natural language processing, and generally working with unstructured data. And that proved to be very efficient. What made it possible also for companies to use deep learning was the availability of a few open data sets. As we know, deep learning is very data hungry. You need a lot of data to train deep learning models. And obviously, having those freely available data sets like ImageNet for computer vision was a big boost. Compute is critical when working with deep learning, and GPUs became available and applicable for other things that 3D games. And they became available on the cloud as well. So all of a sudden it was easier to grab the compute power that you needed and apply it to deep learning problems. And putting everything together, a collection of tools, open source tools mostly, also became available. Libraries like Theano, Torch, later TensorFlow became available for experts mostly, because if you remember those days, it was not so easy to build your models and train them, etc. So you still needed to know quite a bit about machine learning, and developers and generally people without a machine learning background found it difficult to actually train models. But still, this was all a very nice step forward. And so a few years later, this is what a typical machine learning and deep learning project looks like. And although we like to pretend it's very agile and it looks like a flywheel, again, let's be honest, it's really a waterfall project where a lot of time is spent preparing data, cleaning data, and that's going to be at least 50%, maybe up to 80% of the time you spend on your project. And then you move on to training and evaluating results, training again and again, managing infrastructure in the process, and then eventually deploying your model in production, which is typically the hardest part, because now you have to live with that model in production, monitor it, etc., etc. Scale it, not an easy thing. So quite a few hurdles to clear, and unfortunately, the inevitable happened, which is that a lot of companies, a lot of organizations found it really, really difficult to actually deliver deep learning projects in production. And you can see those numbers, over 80% of data science projects actually don't make it into production, which is really a shame. A POC is nice, but business value means you have to deploy in prod. And very few companies manage to do that. Again, only a fraction of companies today actually say that they get business value and adoption on deep learning. So that's a shame, because it's really cool technology, but it's still very challenging to work with. So something a little different is needed. And this is what I call deep learning 2.0. Hopefully it's not deep learning 1.1, but I guess we'll find out. And so we see similar planets aligning, except the technologies have evolved. So neural networks and neural network architectures like CNNs, LSTMs are actually being replaced by a new type of neural architecture called transformers. And I'm sure you've heard about BERT, released by Google a few years ago, 2017 to be precise. Well, this is pretty much the birth of transformers, and now transformers are evolving, and we'll see some examples. Instead of building data sets, practitioners now rely more and more on the technical transfer learning, which we'll discuss in a little more detail. In a nutshell, transfer learning means starting from pre-trained models and applying the knowledge, so to speak, that those models have learned to your own business problem, potentially retraining a little bit in the process. But that's a much simpler thing than just building a huge data set from scratch. GPUs, of course, are still around, but now we see some companies building machine learning hardware, so chips for prediction and training, that have been built for machine learning from the ground up. And as you can guess, these deliver quite a few benefits. And now tools have become friendlier. You don't need to be an expert to get good results. If you're a developer, an application developer, a backend developer, you can train and deploy those models in a much easier way than before, without having to know all the nitty-gritty details that used to come with deep learning. So definitely the learning curve is much flatter now. So let's look at all those 4 new planets. So transformers is both a new model architecture, as I mentioned, but it's also an open source library that Hugging Face, my company, is the steward for, with the help of the community, obviously. And in fact, it's one of the fastest growing open source project in history. You can see the GitHub stars on this slide. Hugging Face transformers are actually the yellow line, and you can see it has the steepest slope, which we're really proud of. And it's pretty funny to see that we're actually growing faster than very popular projects like Kubernetes or Node or PyTorch. So we're really grateful. We see a ton of adoption from the community, and it's not just the community. We also see analysts and generally the IT community acknowledging that transformers are becoming a thing. So transformers are not just for NLP. They started for NLP, but now they're expanding into computer vision, speech and audio, and reinforcement learning, and all kinds of areas. And the Kaggle report shows, as mentioned, that traditional deep learning architectures, if there is such a thing, like RNNs and CNNs, are actually less and less popular, while transformers are more and more popular. So all these point at the fact that transformers are really rising and are becoming the next standard way for a lot of machine learning problems. And just to give you some numbers, on our website called the Hugging Face Hub, huggingface.co, we see about 1 million model downloads every day. That's a good number, and it's rising. Okay, so transformers, the next big thing, we think. Transfer learning, it's the second planet. So transfer learning again means instead of training from scratch on a huge data set that was very painful to build and clean, you start from a pre-trained model that matches the business problem you're trying to solve. And you can see on this slide the list of task types that are available today on the Hugging Face Hub. So as mentioned, lots of NLP, but also computer vision, audio, and some newer task types. So if you find something here that matches your business problem, you go and select a few models for this. They've been pre-trained on a very large data set. I think Wikipedia or even bigger, billions and billions of words, millions and millions of images, and you can test it in a few seconds. I'll show you how on the next slide. So you can very quickly run some tests and figure out, does this model work for me out of the box? And a lot of times it will. So for example, if you need to do, let's say, translation, or you need to do sentiment analysis, most of the time it's going to work out of the box and it's going to be just fine, right? So that's it. You're done. You can take the model and move on to deploying it. So that was fast. Now, sometimes you will need to fine-tune the model. So you will need to specialize the model on your data, and that's the transfer learning part, okay? And so you're going to say, well, now I'm training again, right? So how is that simpler? Well, it is simpler because, A, you need just a little bit of data, right? It's 1 or 2 orders of magnitude less data than training from scratch, and so that's going to be faster to build, faster to train, less expensive, and you need just a few lines of code thanks to the transformers library. We'll see an example in a minute. Okay, transfer learning is much faster than training from scratch because you don't have to build that huge data set, basically. So here's an example of working with the Hugging Face library, transformers library, using the high-level object called pipeline. And you can see in 1 line of code, I can build a model for translation, and it's a multi-language model in this case. So you can see the first token is actually the name of the target language starting from English. So here I'm translating from English to Hungarian, and all it takes is that 1 line of code here, and I can see the result. And then I can build a second pipeline to classify the tokens in my translation. Again, I'm using an off-the-shelf model, so this one is built for token classifications in Hungarian. Okay, I did not train anything here, so that shows you the depth of models that we have on the Hugging Face Hub. And again, I can predict, and you can see the result, right? So dates, persons, ordinals, and GPE means geopolitical entity, so it's a country name in this case. So 5 lines of code, and I'm doing entity extraction with translation in English, from English to Hungarian, right? So that's pretty cool. That's not going to take a lot of time to try, and not a lot of time to deploy either. Okay, so pretty nice. Let me show you a more complex demo. So here I'm still using off-the-shelf models, no training involved, and I'm going to do voice queries on financial documents. Okay, so the 2 models I'm using is first a speech-to-text model with built-in translation. This is a very cool model from Facebook. So I'm going to record a sentence in French. It's going to be translated to English. And that text query is going to be used by the second model to run a semantic search, right? Trying to match the closest sentences in that document corpus, again, which is built from SEC filings, annual reports from large American companies. Okay? Okay, so here's my app. Let's give it a try. Okay, so I'm going to record something here in French, and we're going to run the query, and then I'll show you the code real quick. Okay, so let's try this. Qui est le CFO de Gap? Okay, so I have my clip now. Qui est le CFO de Gap? Okay, and now if I click on submit here, again, this speech is going to be turned into text and translated, and we're going to run the query. All right. So we can see the clock ticking here. It should take a few seconds. And if I scroll down, I can see the what I actually said, which is who's the CFO at Gap. And I can see the top matching documents here, which obviously are the annual report for Gap, right? And we see the top matching sentences in decreasing order. Okay, and that ran for just a few seconds, right? So this is actually public. You can try it for yourself and have fun with it. Let me show you what it entails. So a Spaces is really it's a Git repo where I store code, and that code is automatically run into a Docker container. So if we look at the app here, we can see it's about 100 lines of code, right? And half of that is really for the user interface. So what I'm doing here is I'm loading my models, I'm loading my document corpus, which I processed for semantic search using that sentence transformers model. And then basically I just grab the wave speech and do speech to text and translation on it. And then I run my semantic search on this, right? And that's all there is to it. Right, as you can see, process the speech and find sentences based on the text. nothing hidden, and no training whatsoever. So that's a pretty cool. That's a pretty cool app. Imagine what you would have to do to build everything yourself. It would definitely take a little more than 100 lines of code. Okay. All right. Let's keep exploring transformers. So the next planet that's aligning is machine learning hardware. So far we've mostly relied on GPUs for training, and they're still very nice, but I guess it's good to have more options. And we see companies like Habana, Graphcore, Intel, Qualcomm, AWS, and a few more building specialized chips for training or inference. And in fact, accelerating both makes sense, because if you accelerate training, you can obviously iterate quicker, right? During the same day, you can run your series of training jobs, and instead of having to wait for 12 hours or 24 hours, you can make decisions quicker and converge quicker to a great model that creates business value. Accelerating inference obviously is critical for low latency applications like conversational apps or search, but generally everybody wants to go fast. And of course, if you can predict faster, you increase throughput, you decrease latency, and you can just predict more with the same amount of infrastructure. So your cost performance ratio will be quite nicer as well. So we at Hugging Face are partnering with those companies, and we actually have a dedicated library, which you can find on GitHub, called Optimum, which makes it really easy to work with those chips. You can start from your vanilla Hugging Face code. Generally, it's going to use the trainer API, which is the high-level API to fine-tune models in, again, very little code. And you can just replace a few objects with the hardware-specific objects and accelerate training or accelerate inference. So that's pretty cool, because no one wants to rewrite everything. Go and take a look at the Optimum repo. You'll find some code samples. And we also have getting started posts for all those chips on our blog. Okay. And the last planet is basically putting everything together with developer tools, right? Don't get me wrong, we still need experts and for the really hard problems, but for a lot of problems, for a lot of projects, we think developers can build it all by themselves, right? So we're trying to come up with tools and solutions that are developer friendly and don't require a lot of machine learning expertise, if any. So again, as mentioned, starting from the Hugging Face hub at huggingface.co, you can go and look for data sets if you need to start from scratch because you don't have data for your problem, or maybe you want to augment the data that you have with third-party data. So we have over 4,000 data sets out there. So it's likely you'll find something that you can use. And then, as mentioned before, you can go and look for the models that make sense for your task type and your business problem. We have over 40,000. The number changes every day. By the time you're watching this, it's going to be more than 40,000. And from then on, you can obviously test the models as is, fine-tune the models, either on a Hugging Face dataset, on your own data, maybe both. And you can do this in a number of ways. Of course, you can run this on your own servers, in your Jupyter notebooks. If you have on-prem infrastructure, you can run it in AutoTrain, which is our AutoML service that lets you very easily train on tabular data and NLP data. And this is totally no code, right? You can just click in the UI or use the simple CLI, 0 line of code needed. And as mentioned before, you can use transformers, the trainer API, you can use Optimum to accelerate training, etc. Once you have a model that you like, you can, as mentioned, very easily showcase it in spaces. You just saw an example of that. And then you can deploy it. Again, you can deploy it anywhere you like on your infrastructure. You can deploy it on the Inference API, which is our very own managed API with hardware acceleration. And you can still use Optimum if you'd like to optimize for your own underlying platform. Okay, and you have a model in prod. The last thing I want to mention is we have a deep engineering partnership with AWS. We collaborate on at the product level, at the engineering level, on Amazon SageMaker, which is if you're not familiar with it, it's the machine learning service, the managed machine learning service at AWS, and we make it pretty easy to run, to train and deploy your Hugging Face code on SageMaker using managed infrastructure. Okay, so either way, whether you want to go on-prem or on EC2 or on other virtual machine services or on SageMaker, or we think we have a solution, and we think we can help you fly through that development cycle much faster than before. Okay, so let me quickly show you how to do this on SageMaker. In the interest of time, I won't go through all the details. I'll just show you the highlights, but you can find the URL to this repo in my slides and replay everything. Okay, so what I'm doing here is I'm fine-tuning a DistilBERT model. DistilBERT is a condensed, smaller version of BERT. I'm fine-tuning this model on a product review dataset that I found on the hub, and you can see the URL to this dataset here. Okay, so installing some dependencies, downloading the dataset, and in fact, this dataset has English reviews and a Thai language translation with a flag saying, "Is the Thai translation correct?" So I'll just ignore the Thai part. I'll just keep the English part and the star rating. Okay, so here I'm just simplifying the problem by mapping sentiment to positive or negative. So anything that's 4 and 5 stars is a positive review. Anything lower than 4 is a negative review. So just changing the label here and using some of the APIs in the datasets library to get this done really quickly. Right, so you can see, after a few steps, this is what my dataset looks like: the text and a label that says 0 or 1. Okay, and text and labels are exactly the feature names that DistilBERT expects. Okay, which is why I renamed them. Okay, then I'm tokenizing that text, turning words into integer tokens, and finally uploading the training set and the validation set to S3. Okay, so by now I've got a data set ready to go in S3, and I can actually run my Hugging Face code. Okay, so I've got a training script. You can see it here. It's vanilla transformers code. I could actually run this script on my local machine, passing the appropriate hyperparameters or schemated arguments, etc. This is a SageMaker feature called script mode, which is really handy because you can write the code locally on your machine, test it, and then you can move it as is to SageMaker. Okay, so if you're not familiar with this, just look it up, script mode in SageMaker. Okay, and then I'm loading the data sets inside the script from the training and validation locations in S3, and then using the trainer API, I'm setting up the training arguments. So where's the data, how many epochs to train for, where to log, learning rate, etc. And then the trainer object is where I put everything together, the model, the arguments, and the location of the data sets. And then I call train to fine-tune the model. I call evaluate to compute the validation metrics. And then I save the model and I'm done. Okay, so that code runs inside a Hugging Face container on SageMaker managed infrastructure. Okay, so I just set those hyperparameters: 1 epoch, batch size, name of the model, And then I use this really central object in the SageMaker SDK, which is called the estimator. And here I'm using obviously the Hugging Face estimator, passing my script, passing versions of transformers and PyTorch, and the infrastructure that I want here. So I'm running on a P32XL instance, which is a single GPU instance. And that's all I have to do, right? Then I call fit on this estimator, passing the location of the training and validation set. The training starts automatically, the instance starts, code is downloaded, data is downloaded, and then it trains, okay? And after a little while, training is complete. And then in one line of code, I can just deploy my model. And here I'm deploying on an M5XL, so CPU instance, okay? So after a few minutes, the endpoint is up. I can test it, as you can see here. And when I'm done, I can delete, right? And then it's gone. And if I want to redeploy the model, assuming that I pushed the model to the Hugging Face hub, I can do this very easily, right? So I can just refer to the model on the hub, create this Hugging Face model object with the SageMaker SDK, and call deploy again, right? And then my endpoint is up again, and I can predict again, right? So you could even deploy straight from the hub any of the models that are there, right? For the supported task types. That works. So that's a super simple way to deploy models on AWS if you don't want to manage any infrastructure. And if you want to fine-tune the model, then you can run an example like this one, just fine-tune, deploy, predict, take the endpoint down, redeploy it, etc., etc. Super simple, okay? Again, I went a little faster, but go and check out the repo, run the example. It's very straightforward. All right, well, I think it's time to wrap up. So the key takeaways here are that ML tends to be complicated because we love to make it complicated, right? We love to build complex solutions when they're not really needed. And, you know, we're all guilty of this, myself included. So let's focus on the right things and keep machine learning simple. So first, find a pre-trained model that fits the task and the business problem we're trying to solve. Identify a business KPI that will show success. Machine learning KPIs are nice, you need them, but metrics will only go so far. You need to have some kind of business KPI that tells you, yes, this prediction, this predictive application works and it's actually performing better than whatever we had before. That's really important, and your business stakeholders will want to see that anyway. You can measure the model on real life data, so go and grab whatever data you have. It shouldn't be too clean, it shouldn't be too neat. Sandbox data, test sets, they always look nice. They always perform in a pleasant way, but that's not what you're going to get in real life. So run your real life data on the model, see what happens there. If accuracy or whatever metric you're interested in is good enough, then fine. You're done, move on to deployment, and that's it, the end of the project. If you need to fine tune because maybe you have an NLP application and you have very domain specific vocabulary that doesn't work nice enough in the pre-trained model, then go and fine tune. You've seen how to do it. It's not complicated. And once you have the accuracy that you like, then you can deploy the model. And for many workloads, you need to pay attention to prediction latency. So make sure you have some form of hardware acceleration. Either you use the inference API or you use ML hardware, or you have your own solution with the optimum maybe, but you probably cannot ignore that optimization task. And once you have the latency that you're good with, then you're done, and you can move on to the next project. Tools, libraries, machine learning platforms, and infrastructure. I think they're all there, right? So I don't think it's needed that you go and reinvent that stuff and spend months, sometimes more, rebuilding stuff that's just readily available. And again, we love to build stuff, we love to say that, it's different here, and no, we can't use off-the-shelf stuff, but seriously, that usually doesn't hold. So focus on the business problem, focus on creating value for customers and users, and just go straight to the result, which is, hey, I'm going to use whatever's available now. I'm going to find models, fine tune them, and deploy. And if you do that, you can be in production in a matter of, I'm not going to say days. That would be boasting, even though I know some folks who do that. But in a matter of weeks, you have a production-ready solution out there, right? And it won't take, again, months or years to solve that problem, okay? Which is great. So if you want to get started, if you're completely new to Transformers, I recommend you join our community at huggingface.co. You can sign up in minutes. It's totally free. All you need is a username and an email, so super simple. If you want to learn, I recommend following the Hugging Face course, which again is completely free. You don't need to be a machine learning expert at all. It's really targeted at developers. You can ask questions in the forums. The team will be happy to help. And for companies out there who have strong business use cases and ongoing projects and need help with Transformers, they should take a look at what we call the Expert Acceleration Program, which basically is advanced consulting that we provide end-to-end on your projects, from modeling all the way to production concerns. And for companies who have very strong privacy, security concerns, who cannot run on the public cloud or on multi-tenant platforms, we can also do private deployments. So we can deploy the Hugging Face Hub with models and data sets and the tools that you've heard about today on your own infra. Okay, so talk to us and we can see how to do that nice and easy, right? Thank you very much. In every language out there, now we know how to do translation. If you have questions, if I can help you with projects, if you need anything from Hugging Face, you can contact me at this email address, and you'll find more content on Twitter, Medium, YouTube, etc. Okay, hope this was useful. Hope you had a good time too. And thanks again for listening to me today. And I hope to see you maybe on the road at some point. All right, have a great day. Bye-bye.